everyone. I'm Susan Kish. I'm part of the program committee for the Data for Good program. I'm delighted to welcome you to our first of our paper sessions. Today's first sessions around ethics, fairness, and policy awareness. All papers are going to be on the website at the end of the week. If you'd like to tweet, this is a great place to tweet, so please do so at hashtag D4GX. So I'd like to ask my first speaker to come to the stage. Gabrielle Berman is Ethics and Research Facilitation at UNICEF Innocenti Research Center, and we'll talk about children and the data cycle. Gabrielle.
Thank you. Okay, so very quickly, in terms of what I do, effectively I'm expected to kind of look at all the ethical issues from interviewing children on human rights abuses through to understanding the implications of running UAVs over certain areas in order to capture information and basically to pass through goods from one place to the other. So anything to do with ethics and evidence generation, that's me. So effectively the way I'm talking is the way I think, the way I move. I'm trying to just keep it ahead of the game. I am not a data analyst, and my background originally, I was an economist, but I also worked a lot in human rights. So really trying to keep up, not an expert. Okay, so the things you need to know about me, my slides are really ordinary, okay? I'm not an ICT native, not by a long shot. And my worldview on ethics, ICT, data analytics, etc., let's be really frank and up front, I see ethics as constructive paranoia. Everything that can go wrong, I want to be thinking about what's wrong, okay? This is really important because the reality is in my dialogue with data analysts, everything I do, I'm thinking about what potentially can go wrong. My theory is they can tell me everything that can go right. Between the two of us, we can have discussions. Between the organisations that we work with, we can actually start coming to some happy midpoint. But at the end of the day, if you're wondering where I'm coming from, this is what I'm thinking. This is what I basically train staff to start thinking about these issues. Okay, so this is the first slide. It's always my favourite slide whenever I do training around ethics. It's what's the worst that can happen. It's really useful, kind of get people sufficiently paranoid. So, pedophiles access your data, okay, and get children's details about their location. Children get blacklisted as dissidents. One of the things that we particularly do when we're thinking about ICT is that we think, well, ICT is relatively politically neutral. It's not, okay? And you really have to start thinking about the implications of children online collecting their data. The fact that they're online may be a political act. Okay, a child's geolocational data is used and they're not accepted, whether it's to their school, their education, their parents are not given health insurance, they're rejected for interviews, etc. Okay, the implications are huge, particularly with, the growing use of algorithms. So we've got to really start thinking. We're all very excited, and I acknowledge that there are wonderful applications, and SIDS is one of them, but the reality is that there are also consequences of the same, particularly when applied to social phenomenon. The use of data analytics and algorithms can have huge implications longer term. Okay, a juvenile offender is inaccurately classified and therefore as having a high risk of recidivism, and it increases their sentence. And this is happening. This data is being used for that purpose. Okay, so the reality is if we're using algorithms to determine sentences for children, the implications are huge. So due to increased interoperability of data system, a child of asylum seekers has their opportunity limited because they've got a criminal record. Okay, if the application is rejected, technically they're in on the database with their parents. Okay, huge implications. So a 17-year-old is brought up on pornography charges because of a sexually explicit message. We collect the message, we look at the messages. If governments can access this data, the reality is in certain countries, for a child to actually send images of themselves to their boyfriend, and there's a particular country in Africa that has this particular legislation where if the child that they send it to is 3 years older, okay, not 2 years, but 3 years older, both of them are up on pornography charges, one as a child offender and the other one as an adult offender. Okay, this is the implications that we're talking about. So what are the issues? And this is where people keep coming up to me. They're saying, well, all these issues around algorithms and data, etc., it's no different for children than it is for adults. And the argument is, yes, to a certain extent, a lot of the issues that pertains to adults' data are just as relevant for children. But there are a few kind of categories where this is not the case. So The reality is that children's identities are formed in their early years. And the reality is we are collecting more information about them, and they are providing more information, and this information is being shared. So all the data that is being collected on children, or the data that is basically being disseminating about children, literally from the time some of them are born, the parents, the pictures, etc. All of this information is being collected. All of this information is available and it's accessible, and there are consequences. Okay? Childhood development, their sense of identity very much comes from this. Now, their identity can be their understanding of their own identity, but it can also be their identity in the longer term in terms of other people's perceptions that they may not even be aware of. They may be in a database, for example, some member of the family may have given provided their genetic materials, and some point in the future that genetic material may be used to discriminate against them. Okay, I'm talking about, or as I said, I'm paranoid. It's my job to be paranoid about what can go wrong. Tell me why and how we can prevent this from going wrong, and I'm all ears. Okay, the other issues are in children's understanding. We assume everyone's like, well, the children are digital natives. They know, they understand, they're not there. The data is showing that actually children's understanding of the risks are not sophisticated. They're no more sophisticated than our understanding of the risk. I simply don't understand it, and I spend time trying to research it. So the point is that this notion that children are digital natives and we don't really have to think about it, no, we do. We absolutely do. And this is the big one is informed consent and children's under the law. Children are different under the law. It's as simple as that. Okay, and this, for example, in Europe, the GDPR, the new data protection regulation, actually has very specific conditions about children and data collection and removal of children's data. So yes, children are different because of legal implications. And unknown future applications and use, the reality is we're collecting all this data. This is the first kind of generations that will have data collected over their entire lifespans that will impact their sense of self, will impact their opportunities. So ultimately, how is this data going to be used? Well, that's our responsibility. It is our responsibility to determine how this data eventually gets used. And the big issue is, and particularly with algorithms, and it's a pet peeve of mine because, as I said, some of my work is as much about interviewing children on human rights abuses and doing that properly as it is to kind of thinking about data and algorithms and UAVs, et cetera, and all the technologies, and working with having partners like Facebook, is that ultimately children's voices need to be heard. And what worries me about algorithms is when we start using algorithms instead of actually asking children their opinions, their perspectives, their reflections, then we're going to start having a problem. Because the reality is, particularly with things as sensitive as educational placement, sentencing, the child is an individual. Their voices need to be heard. What worries me is that, yes, it's cheaper. Yes, it's quicker. Yes, it's easier. But at the end of the day, what are the consequences for the individual children? So the particular paper that I wrote with my colleague Kerry Albright looked specifically at kind of various issues and looking at, well, how do we actually, what do we need? What needs to happen in order to protect children? And it kind of looks at, in the past we've kind of very much looked at different players in the data cycle. Okay, so we're looking at, when I talk about data providers, and apparently I was told by a data analyst that that's usually the corporations, et cetera, and the governments that are collecting the data. When I talk about data providers, I'm talking about the children and the parents and the information that is in the data sets, so the people that are in the data sets themselves. So looking at, and this is actually, when I look back on this paper, I think it's very simplistic. And it is. It is absolutely simplistic. It's everything that I walked away from academia. I walked away from academia because I wanted to be applied. Okay, and here it is. I'm giving you a big, the big heading. What do we do? Corporations, what do they need to do? Kind of the suppliers, the collectors of data, the users of data, the data analysts, what do they need to do? They need to do these things. Sharing, privacy, security, nothing there. Nothing there should be new or interesting. Okay? If it is, this is a concern. But for me and for the organisation, for UNICEF, is to actually start thinking about these issues. Okay, what can we do? What are the areas that we, as an organisation, need to start thinking about and actually talking to organisations about? Okay, so practically, what can we do? And these are literally me brainstorming, and I said that brainstorming from, by virtue of the fact that I am not an expert, and I'm not an ICT expert, and I'm not a data analyst, but let's thinking about more information, easier information. Let's see when we talk about what are the privacy conditions, we actually explain to them in child-friendly language. It's already being done, but it should be across the board. It shouldn't be optional within organisations who are collecting children's data. Working with data analysts and users to explain the data. This is a big one. You're assuming that UNICEF actually knows these things. We don't necessarily. We're child protection specialists. We're water and sanitation specialists. Have a conversation in easy language and explain it. Control of private data. Obviously, there are a lot of techniques that are coming out. They're not perfect, and I'm running out of time. Critical appraisal of organisational criteria for buying data. Let's make it explicit. Let's make it public. Sector-wide disclosure of government requests. Some organisations do it, some don't. And appropriately engaging children. Big one. Children don't necessarily have the same perspectives that we do. Algorithmic transparency and sexual disclosure of these calculations of differential privacy and the qualifications. Just an example. Let's start getting some data out and educating people around privacy.
Thank you so much. And we have a packed room. This is fantastic. Unfortunately, as mentioned before, we're not going to have time for questions after this, but this is a great topic, and I encourage people to tweet and share what you've learned and continue the conversation. Our second speaker is Niels Bantilan. Niels is a data scientist at ARENA, and he's going to talk about, is your machine learning algorithmic, and does it perpetuate a social bias? Niels.
Thank you. Okay, my mic is working. Hi, everyone. I'm Niels. Oh, yes, this will be very helpful. And I'm a data scientist at ARENA, which is a startup with a mission to help hospitals reduce bias in their hiring practices while improving organizational outcomes, like reducing their turnover rates. Today, I want to talk to you about something that I think about every day at work, and that is the topic of algorithmic bias and social bias in machine learning algorithms. All right, so when we use the word bias in everyday speech, it typically means that I have a preference for or against something, right? So I might like chocolate and you might like vanilla ice cream, and we can all agree that that's not really problematic. However, there are many forms of bias that are problematic, and one form that I'll be talking about today is algorithmic bias, which I would define as when a set of mathematical rules or heuristics systematically favor one group over another based on a set of attributes. So let's take this one example that was featured and published in ProPublica last year, which is a recidivism risk model. And so what this model does is it takes as input the responses given by some inmates and tries to predict their future risk of reoffending. And so this example really it exposes its social bias when we examine the predictions that it gets wrong. It tends to label black inmates as high risk when they in fact did not reoffend, and it tends to label white inmates as low risk when they do in fact go on to reoffend. And so one thing I just want to highlight here is the link between bias and discrimination, which is that discrimination is something that happens that's when an action is based on biases that result in the unfair treatment of people. So it's easy to see how, when applying these kinds of techniques to socially sensitive decisions, how we can really just perpetuate the social biases that already exist in society. So the problem that, just to make the problem statement clear, machine learning algorithms today are typically optimized only for accuracy. And so we're at risk of reflecting and amplifying real-world social biases. And so maybe instead of thinking of machine learning algorithms, models, as black boxes, maybe we should think about them as mirrors, or maybe both. So we have excellent open source tools for machine learning and data analysis. And I think that we need similarly high quality tools, freely available tools, in the area of algorithmic bias, which is why I created Themis-ml, which is an open source library named after the Greek titan of justice, and just a playful name there. And it implements a fairness-aware machine learning interface, or FMLI, as I like to call it, to measure and reduce social bias in machine learning algorithms. So you have to make certain assumptions and certain definitions of what fairness and what discrimination means. But once you're able to be kind of satisfied with those definitions, one can measure and reduce social bias in algorithms as you define it. So an FMLI really exposes functionality across two dimensions. So the first dimension is discrimination discovery. The task is, given a set of records, a particular measure of social bias, and a particular protected class of interest, for example, race or gender, I want to identify potentially discriminated decision records. And so these are just two ways of doing it. I avoided the math, so I made a pictorial representation of these very concrete methods. And so individual consistency is the idea that I, as an individual, experience similar outcomes as people who are similar to me, ignoring socially sensitive attributes, like, say, the fact that I'm an immigrant. On the other hand, statistical parity is at a group-level measure. And so in this case, it would be comparing immigrants as a population and looking at their outcomes, depending on what the outcome of interest is, say, bank loan approval. And you want to see how they compare with, say, bank loan approval decisions for citizens. The second dimension that FMLI exposes is functionality for reducing bias in machine learning predictions. So the task is similar, but with the main difference of actually learning a model, training a machine learning model that quantifiably produces fairer predictions according to our definition. So in the following section, I'll be making two main assumptions, just to simplify things, because things get complicated really fast. So the first one is I'll be talking mainly in a binary classification setting. So your Y is your outcome of interest, so good credit or bad credit. And Y plus is a beneficial outcome, and Y negative is an adverse outcome. The second set of assumptions I'll be making is your protected class S is composed of two elements, D and A, where D is some putatively disadvantaged group and A is an advantaged group. And so we'll be applying these assumptions to a classic machine learning pipeline where you go from raw data to a system that can make predictions for you about the future. And so the first sensible thing to do is to first measure discrimination or social bias in your raw data, in the predictions in your instantiated models of a fairness unaware system, and the predictions it makes on new unseen data. So this is just one example of how to go about measuring bias. It's called mean difference. What it is it tries to measure how much more does the advantaged group experience the beneficial outcome compared to the disadvantaged group. So if you find that your system is actually reflecting bias that's present in the raw data, you can modify your pipeline in one of three ways. I don't have too much time to go into the nitty-gritty details of this, but the first one is you can pre-process your raw data so that a model that's trained on the modified data makes fair predictions. In this case, with relabeling, what you're essentially doing is you're showing more examples of disadvantaged group folks who experience a positive outcome and more examples of advantaged group folks experiencing the negative outcome. The second thing you can do, and this is, in my opinion, the desirable thing to do, is to directly learn model parameters that produce fair predictions. And so this is one example that I pulled from the literature. It's called the additive counterfactually fair model. And essentially what it assumes is that your protected class attribute is correlated to all of your inputs. So it makes that baseline assumption. And then what you end up doing in the training process is you scrub those correlations from your input, and you use that scrubbed data to learn your outcome Y. And finally, you can do something called post-processing. which takes a fairness unaware model, and you kind of implement some heuristics to make it predict fairer outcomes. So in reject option classification, you take a fairness unaware classifier and say, abstractly, this is like the decision boundary, and these are the positive people, and these are the negative people. You take predictions that are close to the decision boundary, and you flip them. So for disadvantaged folks who experience a negative outcome, like deny loan, you then flip that prediction. You can also do the vice versa, which is flip advantage group folks, but there are a lot of nuances there. Okay, so does this work? Important question. So I implemented a system that kind of tries to take this German credit data. It's freely available. And I'm going to breeze through these next slides, so forgive me. But it essentially tries to predict good or bad credit risk. And there are three potential protected attributes here. And so first, I wanted to measure the degree to which there is bias in the data. And there is higher numbers is more bias. So then I wanted to assess whether or not an algorithm trained on these data actually reflect the biases. And you can see that they actually kind of learn to be a little bit more biased than what the data look like, which is kind of worrying. And then finally, I wanted to assess this fairness utility trade-off, which is the idea that the more fair a model is, the less accurately it'll do on your prediction task. And basically, I wanted to point out this one middle panel, which essentially says that even if you remove protected attributes from your data, it doesn't necessarily lead to a fairer model. And I'm out of time, so now what? We don't want to just blindly apply these methods to everything and then check some boxes and feel good about ourselves, right? So there's a lot of work to be done in many different fields. And these are just some design principles that I came away with, but you can read this in the paper. So thank you.
Thank you very much. As I said, 10 minutes is just a short period of time for a lot of these concepts. But Niels will be here all day and happy to answer additional questions. Our next presenter is Anissa Tanweer. Anissa is a research assistant in Human-Centered Data Science Lab at University of Washington and joins us from Seattle. And she'll talk about mapping for accessibility, a case study in ethics in data science for social good. Anissa.
So that's forward, backward? Okay, cool. Good morning. I'm Anissa Tanweer. I'm a PhD candidate in the Department of Communication at the University of Washington, and I'm also part of a data science ethnography team that's based at the eScience Institute, also at the University of Washington. So what that means as an ethnographer of data science is that I spend some of my time sitting around watching people work on data science problems, some of my time interviewing them, and some of my time actually getting involved in their work. So today I'm going to be talking about a paper I wrote with other members of the data science ethnography team, as well as a team of data science for social good practitioners who were working on building a routing application for people with mobility impairments that was called Access Map. And so in the paper, we kind of go through a case study of some of the various ethical dilemmas they encountered and the approaches they took to solve them. And of course, I don't have time in this 10 minutes to get into all of the details, so I'm just going to highlight two of the issues pretty quickly and then talk about some sort of high-level takeaways from that. So the team wanted to use OpenStreetMap as the base layer, the sidewalk layer for their map. But OSM sidewalk data was really highly concentrated in Seattle. So it would look something like this on the left. This is the downtown area. These are the more peripheral communities. And they realized that this wasn't just a technical challenge, it was also an ethical challenge, because if they relied only on that data, it would compound a disparity that already exists, where the sort of urban core tends to have more informational resources available for the disability community than the peripheral communities. So they decided that a solution to that problem would be to import Seattle's municipal data that was openly available. And with that data, their sidewalk coverage would be much more complete in Seattle. But that also posed another thing that could be framed as an ethical dilemma, because the OSM community has always frowned upon this sort of mass aggregation and import of data algorithmically into the map. And so the team realized that they needed to understand where that position was coming from and why the community felt that way. So they spent a lot of their time over the course of this summer DSSG program trying to figure out, communicating with the OSM community, meeting with local contributors, but also going back through the archive of their listserv logs and engaging in the online forums to figure out why this situation existed. And they realized that there were both technical constraints and also cultural values that the community held near and dear that sort of prevented them from embracing this sort of algorithmic import of data. So in the end, the team actually compromised and instead came up with a way of sort of chunking that import into smaller pieces and developing tools and events to have individual users actually verify the data before it would go into the map. So even though this is like specific to the Access Map team's project, we think it really highlights certain common ethical issues in DSSD that we've already heard about from some of the other speakers. So one of the great things about data science is that oftentimes you can make use of data that is already existing and already available instead of going out and using expensive methods to collect more data. But with that, you run the risk, as we just heard, of compounding disparities within non-representative data. And of course, algorithms can be efficient and accurate and all that. But we also need to hold algorithms accountable to other values that are held closely, such as fairness and creativity and empowerment. And in the paper, we talk about a whole bunch of other ethical issues that we see as being common across the data science for social good space. So things like the evolving opportunities for mischief that are presented by new technologies, subjective and value-laden interpretations that are always at the heart of any data-intensive work, the ability to amplify or suppress certain voices, privacy concerns, and sort of the folly of technological solutionism. So if you're interested in learning how the Access Map team dealt with each of these issues, that's contained in the paper. So just a couple sort of like high-level takeaways from this work. One thing is the importance of setting the stage early for ethical discussions. So I mentioned that as an ethnographer, I sometimes get involved in the work of my community. One of the ways that my team and I do that is by conducting a series of ethics and stakeholder analysis workshops at the beginning of these data science for social good programs. And the intention with that is not to solve all the issues or come up with some easy plan that they can just implement and avoid all of the possible ethical concerns. It's really to set the tone, to provide a common vocabulary and a safe space for raising concerns and thinking through these kinds of things. And in the case of the Access Map team, that really sort of shaped the trajectory of their work for the rest of the summer, and they continued to have these conversations throughout. And that brings me to my second point, which is the importance of recognizing ethical thinking as an emergent phenomenon. And what I mean by that is that even though we did try to set the stage early, they couldn't possibly anticipate every ethical issue that was going to arise in the course of their work. And in fact, we saw this sort of cascading effect, where as they solved one problem, it sort of raised a whole set of other questions. And it was really time-consuming. So a lot of their work was not sitting around on computers writing code. A lot of it looked like this, sitting around a whiteboard and thinking through different scenarios and different use cases and what the implications of that was. To the extent that some of them at times were frustrated that they were sitting around just talking and not necessarily getting to the work of writing code. But at the same time, they realized how important it was to put all this forethought and time and effort into planning. So I think one of the takeaways for anybody who is organizing a program to do data science for social good, or the leader of a data science for social good project, is really the importance of valuing the time and labor that goes into deliberation. And then the third thing is the importance of seeing ethics as an intentional balancing of priorities. So ethical questions aren't always black and white, and it's not necessarily that there's an obviously right way or clearly wrong way of doing things. And that's something that the members of the team felt really strongly about when we were working on this paper together. They were really aware that every decision that they made was ultimately privileging one kind of perspective and experience at the expense of another possible experience and perspective. And so they really saw what they were doing in data science for social good as being not about optimizing for some objective notion of what social good is, but about creating a justified and intentional prioritization of certain values. And that being aware of that and explicitly articulating what is devalued or overlooked in the process was really important to them. So those were all the main points I wanted to make. Just also want to thank all of our sponsors and my study participants as well. Thank you.
Thank you very much. Our closing speaker for this session is Kush Varshney. Kush is a research staff member and manager at IBM Thomas Watson Research Center. He also apparently has T-shirts for us.
Yes, I do.
And he's going to talk about end-to-end fairness and policy around policy-aware machine learning pipelines. So that's what the mystery bag is about.
Exactly.
Good.
All right.
Kush, thank you.
Yep, and we have the clicker. Thanks. And yeah, this is joint work with 3 researchers at our IBM India Research Lab, Samiola Sheikh, Harith Vishwakarma, and Samit Mehta, and 2 of my colleagues at the T.J. Watson Research Center, Karthikeyan Natesan Ramamurthy, and Dennis Way. Right, so the topic is an end-to-end machine learning pipeline, and it builds directly on top of what Niels talked about, so kind of one level above. Right, so data pipelines are messy, as I think all of us will agree. So there's all sorts of things that have to happen. So data extraction, storage, exploratory data analysis, modeling and analysis and visualization and so on. So the issues that go along with this is that there's often different entities who are performing the different stages. It's very easy to lose track of the semantics of the data as this whole pipeline process is going along. And it's also easy to forget that there are actually people behind these data points. And in particular, what this implies is that all of the fairness and non-discrimination policies that might be of interest could get lost as we're going throughout the process. And this is all assuming that there's people actually involved in setting up all these stages and doing them, but eventually we have a vision that a lot of it will be automated and that there will be machines composing models themselves and setting up these pipelines themselves, right? So the other sort of thing is an issue or problem is that fairness is not universally defined, right? So in certain contexts, there's certain protected attributes that are relevant and not in others. So the example that Niels gave of the ice cream flavors, right? So there might be some situation in which ice cream flavor preference is a protected attribute. I can't think of any, but I'm sure there must be one. But seriously, I mean, there's different attributes. Sometimes they are and sometimes they aren't protected, right? And it's also often the case that fairness policies are buried in natural language documents, and it's very hard to kind of extract what those are for people and even harder for machines. So these are just some fairness policies I pulled off of the web for employment, housing. Some school district has something, some medical center has something, and they're all different from each other. And they're all specified in different words. Right? So in terms of our problem statement then, so I think Niels already went and did a good job of defining what sensitive features are and what protected groups are. So what we want to do is develop or have a fairness system, a machine learning system that doesn't discriminate among various protected groups, right? So the same thing that we have just heard.
So now for us, if you are starting with some sort of policy document, this is the same prison recidivism data set that we've heard about twice already. So there was a court case in the state of Wisconsin just recently. Loomis is the person who was challenging the algorithm. So the decision in that case explicitly says that COMPAS assessments should not take gender into account, but it says it in a sort of weird legal sort of language, right? So what we're proposing is, can we offer an end-to-end solution that can interpret policies like these and alert for possible violations by the ML system using many of the methods that Niels talked about? And the primary goal here is to ensure that policy compliance does happen throughout the process without much manual effort and in an auditable way. So here's a system architecture that we're envisioning. So we'll have policy documents, we'll have training data, and we'll have our machine learning system. And all of those will feed into a fairness system that will alert users or others that there might be fairness violations happening, and done in such a way that we are able to actually audit this. And we're proposing to use blockchain, which is a distributed ledger technology for that. So if we start with these natural language policies, so this is a snippet of that same Loomis decision. So how do we know that if a particular phrase is in that document that it actually maps to a particular data set that we're interested in? So there has to be some sort of approach, some knowledge and reasoning approach that takes this text and does some sort of entity extraction and figures out that there is a sensitive entity in there. Right? So that's one key step that needs to be part of the system. And then once you've done that, then you again have to kind of encode this in some sort of schema or some sort of representation for machines to work with. Right? So there's various types of data that we deal with, of course. So there's structured and unstructured data, and there's different sorts of machine learning algorithms at work as well. In some, it's very obvious which of the inputs features are part of the final decision rule, and some that's not the case. So these would be kind of more interpretable methods. So if you have structured data and you know which features are being used, it's fairly easy to do such a mapping. But in these other cases, there's much more work involved. So in the case of the first one, I mean the easy one, then you just do the mapping. If you are, in the case where you have a black box sort of model, then you can just assume that all the fields will be subject to the mapping. Right? So you have to do this sort of sensitive entity to data schema mapping. And this can be done fairly straightforwardly. But the hard case is when you have unstructured data. So this entity extraction needs to do some advanced sort of techniques of string matching or semantic relatedness and so on to finally get to the actual attributes in a particular data set and do that matching. And then finally, in terms of the immutable auditing, so as all of this is happening, what we want to make sure is that at any point in time, for anyone in any place, that they should be able to see what the pipeline was doing. So we should be able to check for any of the fields, any of the protected attributes, any of the fairness checks that are happening throughout, and do that in a distributed ledger. And then that will produce the runtime alerts. So to conclude, this is more of a vision than anything else. So I would encourage all of you to talk to me about actually making this a real world thing. So we've established a generic architecture for an end-to-end fairness policy pipeline in machine learning. There's standardization where data owners can use our system to specify policies directly into machine-readable sort of formats. And the goals that we want to achieve through such an approach are reduction in the time and manual effort to make this happen, and to have publicly accessible logs so that all of this can be checked. So just to wrap up, as we already heard, I have T-shirts to give out, but we're kind of reorganizing IBM Research and creating this new entity called IBM Research AI. And one of the focus areas that we're hiring a lot of research staff members for very quickly is around fairness, accountability, and transparency, in addition to many other sort of things. So if any of you guys are interested in a career at IBM Research, please come talk to me as well. Thank you.
Thank you. Now we have a whopping 4 minutes. So we can probably do 1 or 2 questions if you guys are quick. So zip up your hands. Yes, thank you. Wait, can you, because it's being broadcast downstairs, just say your name and your institution.
Hi, I'm Katie. My name is Katie Ornstein. I'm from Riverdale Country School here in New York. I was wondering what the panelists' advice would be for very young AI students on a collegiate or even secondary school level, because so little of computer science education has an ethics bent to it. From the other side of that, what do you want educators to be thinking about?
Great question. Who wants to take that?
I mean, where you start, well, basically, let's first actually get into the system as a core component. I mean, this is ultimately the problem, is that we have to start thinking about it. We can't even begin until we actually have this agreement that this is an integral part of kind of thinking around these issues. And I think in terms of, one, you've got to just start thinking about, well, what kind of pedagogy we're going to have, et cetera. But I think that requires actually this kind of joint conversation between kind of those who work with children and, in fact, data analysts, et cetera. And kind of, so you've got this kind of interactive creation, I suppose, of kind of various modules, et cetera, that are built into the curriculum itself. So I think, but first and foremost, let's get it on the agenda. I mean, this is something we've been trying for a very, very long time, to kind of really push this idea that none of this can work, none of this kind of accountability, et cetera, can work without actually having systems in place that allow for the education for us to all get on the same page, even if it's simplistically. We won't always be on the same page in terms of understanding, but there are certain kind of principles and ideas, et cetera, that can actually be imbued, and the dialogue can actually happen.
I can say a couple of words as well. And so I would also argue that it shouldn't be, only discussed in machine learning or AI sort of classes or parts of the curriculum. So I think it has to go both ways. So in social studies classes and so on, there has to be some more discussion of how data is now being used. So I think that is important as well.
Thank you. A second question. Otherwise, can we all clap hands for our speakers? That was great.